And now we're going to graph the function and its inverse on the same axis. We'll start with the original function, and this is simply the parent function 1 over x, where recall that you have the branches in quadrant 1 and quadrant 3, but this is a graph that has been shifted 2 units to the right. So we'll have a vertical asymptote at x equals 2. So once we do that, it's going to look like so. Next, we want to graph the inverse. To do that, all we have to do is take a few points from the original graph, swap the x and y values, and it's going to give us the inverse, and you'll notice it'll form a mirror image about the line y equals x. And there you have the inverse and its function. Lastly, we're going to give the domain and range of the function and its inverse. So the domain and range of an inverse function and the original function are simply interchanged, just like you would swap the x and y when you have the ordered pairs. So here we have the original function here. If to find the domain, recall you take the bottom, set it equal to 0, and solve for x. In this case, x would be 2. So that means 2 is the only number that I'm not allowed to plug into this function. Why? Because it would make the bottom undefined. So to write it in interval notation form, the domain would be all numbers except 2. So if that is the domain of the original function, it becomes the range of the inverse. And now while we're here, let's find the domain of the inverse function. What numbers are we allowed or not allowed to plug in? Well, we can see here that the only number that we're not allowed to plug in here is a 0. Why? Because a 0 there would make it undefined. We can plug in any other number and it would be okay. So the only number excluded from this domain would be 0. So to write it in interval notation form, this is what it looks like. So if that's the domain of the inverse, it becomes the range of the original function.